Okay, so yesterday we learned about measures of center, and now we're going to talk about measure of dispersion, and that's basically how far is something spread out. So we have two categories. We have the range, where it is, this covers all numbers are included within the range, but the way that we calculate it is we want to look at the greatest number minus the smallest number. And so sometimes we'll actually say that it ranges from, and then we'll go smallest to greatest, but the range itself is the number, or the difference between the greatest number and the smallest number. Standard deviation is a slightly more, it is basically the distance that a number is from the mean. And you're going to see us refer to the mean with a variable instead of the word. We're using an x with a bar over it, okay? And you would read that as x bar, okay? And we have a way of calculating the standard deviation, and then we're going to use that information to have almost like a smaller range to summarize the majority of the data. So to actually calculate standard deviation, we have this big long formula. So x1, x2, x3, x4, all the way up to xn, these are the actual terms, not the terms, I'm sorry, the numbers. So this is our first number, our second number, our third number. And we're going to go all the way up to our last number. So that means that n is the number of numbers. So just like we're finding the average, we're going to find the difference between these, okay? So that's why we are subtracting. So difference between that and the mean, we're seeing how far away from the mean it is. We square that value, so all of them are being squared. Essentially, that's one way to get rid of the negative, so you just square it. Find the sum and then divide, so you're finding the average, and then we're going to square root very, very last. Okay? And again, x bar is the mean. So we first must calculate that. So if we look at a stem and leaf plot, we need to look at the key in order to decipher what it's telling us. So this key is telling us that every number on the left is kind of like a tens digit, or it's 70, and then every number on the right is the ones digit. So all of these numbers over here represent a new number. And luckily, when we do stem and leaf plots, they go in ascending order. So they start with the smallest and they go up to the largest. So this line 5 right here, that is 65. And then we have 70, 75, and another 75. Okay, and so we can continue this on. So we have 80, 84, and 85. And our very last one is 94. Oops, sorry. Okay. So in order to find the average, we're going to have to add all these up to find the sum. And then we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8. Okay? And so that's going to give us our x bar. Once we calculate that using a calculator or a computer or something like that, we would get 78.5. So that is my mean. And essentially, my standard deviation is going to help me decide how far maybe this number is from the mean, or how far this number is from the mean. It can also tell us what range will include the majority of the numbers, but maybe not all of them. So we're going to come down here, and we're going to plug this into this giant equation. Okay, and I went ahead and already plugged it in and solved. And so we started with 65, so that's where the 65 here comes from, this 65 here, okay? And then we continue up until we get all the way to our last number. So we have 70, 75. Now, I have two 75s, so I didn't necessarily need to do that twice. I could have just put a 2 in front and then not done that second one, but it's fine. Oops. Why is that not erasing? Okay, so we're going to make sure that we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. And then we went ahead and subtracted and then squared. So you have to subtract first and then square second. Subtract and then squared. And so those are the values that are above. Okay? When you go to actually calculate this, and you add all of these numbers up, we get the square root of 594 divided by 8. Okay? So then we need to divide 594 by 8, which is the square root of 74.25. When we square root that, we get 8.6. This would be 8.62. We're just going to round it to 8.6. Okay, so that is my standard deviation. So sometimes I shorten it to standard deviation as SD. So that is 8.6. We can also talk about the range. And so that would be 94 minus 65. So 94 minus 65, and that is 29. Okay, so these numbers have a range of 29. That could be big, it could be small, it depends on what we're talking about. And then the standard deviation is 8.6. So there's this thing called the normal curve, and when we include standard deviations, we can find ways to get a smaller range that doesn't include necessarily all of the numbers. So if we take our average, 78.5, and I add one standard deviation and I subtract one standard deviation, it's going to give me two numbers. So if we do 78.5 minus that, we get 69.9, and then we get 78.5 plus 8.6, 87.1. So majority of numbers, it's roughly close to 70%, will be between these. And if we look, the only two numbers that actually aren't between those are the first and last. So we have 6 out of 8 numbers between that, which is 75%. So that's a pretty strong majority. And then once you look at this bell curve, okay, we have our mean in the middle. Okay, our mean comes right down the middle. And then we have one standard deviation to the left or to the right. Okay, now the more numbers you have, the more closer this will be to 68%. Okay, and then if you go another standard deviation out, so then we have 2 out, then that's going to include around 95% of our data. And then you could go a third time, in which case you're literally only missing 0.3%. And that includes 99.7. Now, you don't necessarily need to know this graph, okay? But I wanted to show it to you so as to why we use standard deviation, okay? So basically, you normally want to do average or above average, right? But if you're above average and you're within that one standard deviation, then so is a lot of other people. So generally, we want to... if we want to be exceptional or above majority, then we need to somehow make it past that standard deviation. So how big the standard deviation will totally depend on our numbers, because it's all dependent on the mean and the numbers themselves. Okay? But that is the quick summary of how to find standard deviation. You will not need to memorize this equation. You'll have it provided for you on the test, or you'll get it on a note card. Let me know if you have questions when you do your homework.